Hey guys, we have finished Unit 3. We are moving on to Unit 4. As you know, we did 4.1 as part of Unit 3, and that's actually all of Unit 4 I think we will do in this class. So Unit 4 begins with section 5.1. We are talking about exponents, mostly the rules of exponents and how to simplify them today. All right, so exponents that are natural numbers, which is all the exponents we will be using, are shorthand notation for repeating factor. A factor means multiplication. So exponents are a shortcut to multiplication. Okay. An exponent tells us how many times to let's start with the bigger number is the base and the smaller number is called the exponent, or you could call it the power. So you could say 3 to the power of 4 or 3 exponent 4. Okay. The exponent tells us how many times to multiply the base by itself. So 3 to the 4th, yes. 3 to the 4th just means multiply 3 4 times, okay? And in PEMDAS, what this is saying is in PEMDAS, parentheses, exponents, multiply, divide, add, subtract. Exponent is second. So it's it's when you do before you multiply, before you divide, before you add, or before you subtract, okay? All right, so let's just do a quick example. 5 times 5 times 5 is 125. So we asked 5 to multiply it by itself 3 times. 5 caret, this is the caret button, 5 caret 3, 125. Okay. The product rule, product means multiplication. And the product rule means if m and n are integers and a is a real number, a to the power of m times a to the power of n becomes a to the power of m plus n. Okay. If you have a base, this is our base. And m and n are exponents. If you have a base raised to any power or to any exponent, and you are multiplying that base by the same base raised to any power, you keep the base and add the exponents. Okay, let's write that down. So for multiplication, keep the base and add the exponents. All right, that's our rule. Keep the base, add the exponents. So here we have 3 to the power of 2 times 3 to the power of 4. It's multiplication, so we use the product rule. 3, 2 plus 4 becomes 3 to the 6th, and 3 to the 6th power is actually 729. Okay, so we're trying to simplify it as well as we can. Because we know it's a number, we can put that in our calculator and find the answer. You also always want positive exponents in your answer. So never end with a negative. Keep going until you don't have a negative anymore. All right. Okay. Next, we have just letters. Interesting. So this is z to the third plus, sorry, multiplied by z squared. So we're going to say 3 plus 2 multiplied by z to the fifth. So we're going to say plus 5. 3 plus 2 plus 5 becomes z to the 10th. And because we don't know the value of z, we can now leave it just like that. It is finished. All right. So a is the base, m is the exponent, 3 and 4, these are considered coefficients. A coefficient is a number multiplied by a variable. The number multiplied by a variable. Or you could say the number in front of the variable, okay? The coefficients get multiplied together and then the variables get multiplied together. So we're putting like terms together. So here we would say 3 and 4 go together, and then y2, ooh, sorry, it's a negative 4. y2 and then y4 become y2 plus 4. 3 times negative 4 is negative 12. y2 times y to the fourth becomes y to the sixth. And since I don't know what y is, that is as simple as I can make it. Okay. The next rule is the zero exponent rule. Any number except 0 raised to 0, or to the exponent of 0, will give you a 1. Okay. Any number, 100 to the 0 power, oops, calculator's not on. 100 to the 0 power will give you 1. Negative 6 to the 0 power will give you 1. Any number raised to the 0 power will give you 1. Okay, so the 0 exponent is a non-zero, that just means any number but 0, a non-zero number with an exponent 0 will equal 1. I would also say it a non-zero number raised to 0 power. You might hear that. Raised to the 0 power. And that's the same way of saying with an exponent of 0. Raised to the 0 power means with an exponent of 0 will equal 1. Okay, so 5 to the 0 power is just 1. It does not matter what's any of these are. If we raise them all to 0, it'll be 1. So let's make something up. Let's make something up. We'll give them numbers. 8 times, so you can see it. 8 times 7 times 3 to the third. Oops. 8 times 7 times 3 to the third to the 0 power equals 1, okay? This one does not equal 1, okay? So for this one, do you see how I multiplied them and only the 3 got the exponent 3? So the only base for the exponent was the number or letter right below it, okay? So for this 3, z is the only base for the exponent 3. So when I stretch it out, I said x times y, no 3, times z to the 3rd, okay? If it looked differently, if it looked something more like x, y, z to the 3rd, then it would be x to the 3rd times y to the 3rd times z to the 3rd, okay? So for this one, for this 0, the only base is the x. It's not the negative sign. Let me give you 3 different pictures. So we have 3 to the 0, negative 3 to the 0, and parentheses, negative 3 to the 0. How are these different? They all have different bases, okay? So here, the base is 3. We'd say a base of 3. Well, I guess they don't have different bases because here we also have a base of 3. And here we have a base of negative 3 because the parentheses tells us what the base is, okay? So 3 to the 0 power is 1. Okay. Negative 3 to the 0 power is negative 1. Because my base is only the number 3, and then I may add the negative on later. But if I put the negative into the parentheses and it becomes part of my base, it becomes positive 1. Okay? So without parentheses, the only base for the exponent is the number right below it. So this is actually negative x to the 0. X to the 0, no matter what x is 1. Even if it was negative 2. Oh, sorry, because we have it in parentheses. Negative 2 to the 0, it would still be positive 1, okay? So negative 1. So negative x to the 0 power is negative 1. Negative, we'll say x was negative 5 to the 0 power is negative 1. Negative x is 8 to the 0 power is negative 1. No matter what number we put in, the answer will be negative 1 because the 0 only goes to the x. We add the negative at the end. All right, quotient, sorry. Quotient means the answer to a division problem. So we say the quotient rule is the division rule. And just like last time, we said, if you have a base raised to a power times that same base raised to a power, keep the base and add the exponents. Here, we keep the base and subtract the exponents, okay? So for division, keep the base and subtract the exponents. Okay, and make sure you start with the number on top and subtract the number on the bottom. Start with the numerator or the top number, subtract the bottom number from the top number. All right, shall we work these examples? So we have 6 to the 10th power divided by 6 to the 2nd power, and we're just going to subtract m minus n, right? So that becomes 6 to the 10th minus 2, which is 6 to the 8th, which I can turn into a number, actually. 6 to the 8th power is 1,679,616. So that is 1,679,616. All right, letter B. Y to the 6th divided by y to the 2nd. Y 6 minus 2, y to the 4th. I can't go any further because I don't know what y is. All right, here is another coefficient. So we do the coefficients separately from the variables. Remember, we did 3 times -4 is -12. So here we're going to say 36 divided by 9. 36 divided by 9 is 4. So we're just simplifying. That becomes 4x to the 5th. This is an understood x to the 1st, right? So x to the 5th minus 1 is 4x to the 4th. Because I don't know what x is, that's as far as I can go. Our answer is 4x to the 4th. All right, another one with coefficients. We can't divide. 15 doesn't go into 10, but we can simplify it, right? 10 and 15, we can both divide by 5, right? And if I divide 10 by 5, it's 2, and 15 by 5, it's 3. So on top, we'll have 2, and on the bottom, we'll have a 3. Because 10 divided by 15 is 2/3, sorry. Okay, so I'm going to change that right now from 10/15 to 2/3. And then I'm going to take my exponents out of the fraction. A to the 7th divided by a to the 5th means a 7 minus 5. B 9 minus 9. Okay, let's simplify this even further. So we got 2/3. 7 minus 5 is 2. So we'll say a to the 2nd. 9 minus 9 is 0. So we know that b to the 0 power is 1. So that's 2/3 a squared times 1, which we can just say is 2/3 a squared. Final answer. We simplified it a lot. Okay. Negative exponents. Because you must always leave your answer in the positive form. Okay. Let's review. What is the job of an exponent? What is the job of an exponent? Remember, if it was 3 to the 4th, that meant 3 times itself 4 times. 1, 2, 3, 4. That becomes 81. Okay. What if it's a negative? How do I multiply 3 times itself -4 times? I don't know. So I reciprocate it. And to reciprocate means to flip. So a to the negative n is the same as 1 over a to the positive n. 3 to the fourth becomes 81. 3 to the negative fourth, we're going to reciprocate. Remember, any number you want to turn into a fraction, you just put it over 1. So your reciprocal of 3 over 1 is 1 over 3. And then when you reciprocate, you lose the negative. Okay? And that will equal 1 divided by 3 to the fourth oops, we need it in a fraction, is 1 over 81. Okay, so we have 81, and if we turn it into a negative, or sorry, if that were a negative, it would just be 1 over 81. So it's doing the same thing, but turning it into a much smaller number because that's a fraction. Okay. So simplify and write with only positive exponents, always. 3 to the negative 2. So there's my original. I'm going to reciprocate, okay? So that is 1 over 3 squared, which is 1 over 3 times 3 is 9. Done, okay? This one, same thing. I'm going to reciprocate so that it's a positive 7. Now it's 1 over x to the positive 7 equals, that's all I can do. Should write it again. I don't know what number x is, so I can't do anything else. All right. Here, just like we talked about on this one, the exponent is only with the closest term. The exponent is only with the closest term. So the negative 4 is only with the x, okay? So now I have, let's separate it out, 2 times 2 times x to the fourth, negative fourth, sorry. So I can leave the 2 on the top, and I'm going to reciprocate the x to the fourth so that it's a positive 4, just like we did here and here. My errors are making it confusing. So I did just what I did here, and then I'm going to put it back together. So 2 times 1 is 2, and x to the fourth on the bottom, okay? Or if it makes sense to you, you could just quickly go 2x to the fourth, sorry, negative fourth. I know this is negative and it needs to go down, but 2 does not. And so you can simply rewrite it as 2 over x to the fourth, okay? If that makes sense to you, if that is very clear. Let's do some more examples. Let's mix these together. Example 5 says, simplify and write using only positives. Now, I guess we're not mixing anything up yet. I spoke too soon. All right. Remember, this is now negative x to the negative third. The negative 3 only goes with the x. Ooh. You know what? This one's easier. I'm going to start over here. I'm going to start here. You can wait. Okay. So this shows me that the negative 3 is the whole base, right? The parentheses. So I'm going to say parentheses negative 3 to the negative 2 is over 1, right? And understood 1. And I know that I need to move all of this down because it has a negative exponent. All right, so I'm going to flip these. 1 over -3 to the -2 power. And then I can just put that in my calculator. Oh, sorry, now it's +2. So sorry. Okay. -3 to the second power is 9. Okay. Now let's look at this one. This one does not include the negative in the base. So that negative we eliminated by keeping it with the +2. But we can't eliminate this one. So that becomes -3 to the -2 over 1. I need to flip it. So it's going to become 1 over 3 to the -2. And I didn't need to move the negative. I mean, it doesn't really matter. It's just the negative is not inside the parentheses, right? So -1 over 3 to the 2 is -1/9. So you see how these are almost the same, right? We have a -1/9 and we have a +1/9 because the negative was either included in the parentheses or we left it out. Either way, we had to move the part with the exponent down to get a positive exponent. But in this case, it did not include the negative, so the negative stayed out. In this case, it did include the negative, and the negative became a positive, right? Because -3 times -3 is a +9. But a -3 times 3 is a -9. All right, so this last one is -x to the -3 over 1. We need to move only the x minus 3 so that negative stays outside of that. -1 over x to a +3. And that's all we can do because we don't know what x is. Those are my answers. All right, again, example 6. Simplify and write using positive exponents only. If the negative exponent is on the bottom, we still reciprocate by moving it up. Moving it up. Moving it down. So everything is just moving across the fraction bar or the division sign. Okay. So 1 over x to the -3, x to the -3 is going to go up. So now it's x to the 3rd. You could put the 1 back on the bottom, or you could just say, I know that's x to the 3rd. Any number divided by 1 is itself. This one, we're going to move both of them. So y to the -4th now has to be on the bottom. Sorry, on the top, and it becomes a positive. And then the x to the -2 goes to the bottom, and it's a positive. We're flipping them. One more set of examples. We're not going to do example 8. It doesn't come up. That would just be x to the 6a, right? But we don't need to do that. We're not going to do that. All right. Simplify and write using positive exponents only. So we have m to the 5th divided by m to the 15th. M5 minus 15, because for the quotient rule, or to divide, you subtract if the base is the same. 5 minus 15 is -10. If I have a -10, I now need to move it, right? So it's a -10 over 1, and I'm going to move it down to the bottom. So now it becomes 1 over with a positive 10. I think I'm going to keep using this, boxing my answers. It looks way better, much clearer. Okay, so there's my answer. M to the 5th divided by m to the 15th becomes 1 divided by m over 10. All right, letter B. Letter B is 4 to the 2nd power divided by 4 to the 5th power. So I've heard people ask, can I just divide 4 by 4 like we did with 36 and 9, right? 36 and 9 became 4. So couldn't 4 by 4 become 1? It cannot, because it's not, here are two different things. 4 by 4 is 1, that is true, but 4 to the 2nd power, or 4 exponent 2, is actually 16, and 4 exponent 5 is actually 1024. So we can't just say that 16 divided by 1024 is 1. It wouldn't be, right? So that is why when we said PEMDAS, right? We want to use our exponents or simplify our exponents before we multiply or before we divide, okay? So it can't be 4 divided by 4. It has to be 4 to the 2nd power divided by 4 to the 5th power, just to make that clear. All right, so 4 to the 2nd power divided by 4 to the 5th power, 4, 2 minus 5 is 4 to the negative 3rd, right? And so I need to move that down. Over 1, move that down. Now it's 1 over 4 to the positive 3. 4 to the 3rd power is 64. So it's 1 over 64 is my final answer. And I want to show you that 16 divided by 1024. If we turn that into a simplified fraction, it would be the same as the work we got. Okay. So that's our answer for B, 1 over 64. Y to the negative 10th times y to the 3rd. That is y to the negative 10th plus 3, which becomes y to the negative 7th, which means it is 1 over y to the 7th, right? We took that, we need to move it down. Letter D is q to the 5th minus negative 4, because it's divided by q to the negative 4th. Subtracting a negative becomes a positive, so we have q 5 plus 4, which is q to the 9th. And that's all I know about it. It is q to the 9th, okay? Letter E. Letter E. I'm going to do it over here so I have more space. Letter E is 10x to the negative 8th, y to the 5th over 20x y to the negative 5th also. Is that true? Did I write it correctly? Okay. I like to make all my exponents positive right away. Okay. So that means I need x to the negative 8 down here. I need y to the negative 5th up here. So I'm going to move them right now. 10 y to the 5th over 20 x to the 8th x, and that y to the 5th goes up. Okay. So this y became positive, this x became positive. Now I'm going to simplify, first starting with those coefficients. The coefficient 10 and 20, we can divide both of those by 10, right? And we get 1/2. 10 divided by 10, 20 divided by 10, 1 and 2. So 10 divided by 20 is 1/2. Okay, so I'm going to change this to 1/2. Y, sorry, let me delete that. Y 5 plus 5 over x 8 plus 1. I'm going to write it again. 1 for y to the 10th, 2 x to the 9th. I don't even need that 1. I could just say it's y to the 10th over 2 x to the 9th. Because 1 times y to the 10th is just y to the 10th. Okay. Here are my answers. All right. This one, you can do the same thing. If you want, you can move the x to the -1 down or not. You can also leave it with the 4. Okay. So if I left it with the 4, it would look like this. 4. Well, let's rewrite the whole thing. 4x to the -1, x to the 5th, divided by x to the 7th. Okay. The -1 is only with the x. So I'm going to leave the 4 on top. And I'm going to, or sorry, we're not doing that. We're just going to combine the x's. 4x -1 plus 5, right? That combines those two multiplication. That multiplication expression over x to the 7th. So that is now 4x to the 4th over x to the 7th. Now I'm going to subtract, or sorry, divide x to the 4th and x to the 7th. So that is 4x to the 4th minus 7, which is 4x to the -3. So I need x to the -3 to go down. So my final answer will be 4 over x to the -3. 4 over x to the x to the 3rd. I always forget to change it to positive. 4 over x to the 3rd. All right. Another way to do it would be to move that x to the -1 right away, and then kind of set it up as a, well, I'll show you. So here we have 4x to the -1 times x to the 5th divided by x to the 7th. And I said, I want to move this down right now. Yeah. So now I have 4x to the 5th, x to the 7th times x1, right? So you can, well, let's just keep going. 4x to the 5th over x. They're being multiplied, so now it's x to the 8th, right? 5 minus 8 is going to give me that -3 again, and I'll have to put it back on the bottom. Or I can say 4, and then I can draw 5 x's. 1, 2, 3, 4, 5. an elimination method. Then I'll write 8x's here, right? And then you can just cancel them out. 1, 2, 3, 4, 5. So now I have 4 over x to the third. If that seems faster to you, you are welcome to do it that way. And you could do that with everything, right? You could move that 8. As soon as you get to here, you can put a bunch of, well, those don't have the same letters on top. But here, no, it's a negative. All right, here. Here you could go 4 times 4. And this is 4 times 4 times 4 times 4 times 4. I know that that's going to be 1 over 4 to the third. So you're welcome to do that with any like terms you can find. All right, and we are not doing example 8, so that is the end of 5.1. Thank you for watching and have a good one. Email me with any questions.